All right, hello my friends. So in this video, we're going to work through a quick little example of finding total demand. And then after that, I'm going to use this example to pontificate at you a little bit about what consumer surplus does and does not mean, right? And how we're going to be doing welfare analysis. So as before, this video is entirely optional. You don't have to watch this video, but feel free to watch along if it would be helpful for you to get some extra practice. Okay. So the problem I'm laying out is a problem where we've got two individuals, Anna and Beth, both of whom have identical preferences for housing and food, right? For both of them, their preferences can be described by a utility function in terms of H and F of 2 ln H plus ln F, right? Cobb-Douglas preferences. And what we want to know is what our overall demand for housing is going to be, right? Meaning we want to find the amount of housing that both consumers are going to buy together at any given price for housing pH. Okay, so how are we going to start with this problem? Well, the first thing is let's start with the goal here, right? What do we need in order to know total demand for housing? We know that our total demand is going to be the sum of each individual's demand, right? So we can say quantity demanded total as a function of pH, right, has to equal demand from Anna, which I'll call QDA pH, plus demand from Beth, right? And these, of course, are equivalent to just knowing H as a function of price of H, right? Beth's optimal choice of housing and Anna's optimal choice of housing. Sorry, mixed up. Anna's optimal choice, Beth's optimal choice. Okay, so this is what we need, right? We need to figure out how much housing Anna's going to consume, how much housing Beth is going to consume at a given price. And how we're going to do that is we're going to solve an ordinary optimization problem, right? Find their optimal choice of housing and food. But instead of doing so for a specific price, we'll do so keeping price as a variable, right, for any given price. So let's start with Anna. So for Anna, we know that she's going to have a budget constraint given by pH times H plus PF times F has to be less than or equal to $12,000, right? Which means if we draw ourselves a little picture, we're just going to have a straight line like this, where the most housing she could afford would be 12,000 over pH. The most food she could afford would be 12,000. Right? Oh, sorry. We have a PF, which is going to be 1. Great. Okay. So this is our budget constraint. The other thing we need is our preferences, right? So once we know what our budget looks like, let's try to find our MRS. Which is going to be du/dH over du/dF, right? du/dH is going to be 2 over H. du/dF is going to be 1 over F. So this is going to be 2F over H. Do a quick gut check, right? The more food we have, the more food we're willing to give up for a little bit of housing. The more housing we have, the less food we're willing to give up for a little bit of housing. That makes sense. We have a 2 here on top, which makes sense because I value housing more than I value food, right? Okay, so now that we've done that, let's look for what kind of solutions. We'll call this 1 is our budget constraint, 2 is our MRS, 3 is solutions. Is it possible that we'll have a corner solution where she buys only food? No, right? If she bought only food, her MRS would be infinity because housing would be 0. There's no way that infinity is going to be less than the slope of her budget constraint. Same thing for a horizontal corner, right? If she bought all housing and no food, her MRS would be 0. She would be just desperate for a little bit of food. So only an interior solution, right? We have to have a solution that looks like this. Great, okay. So what do we do to find an interior solution? Well, we're going to need 2 things. We're going to need, for an interior solution, First of all, that the slope of her indifference curve is equal to the slope of her budget constraint, right? MRS equals price ratio. And second, we're going to need that she consumes her whole budget. Okay, so let's start here. This is going to tell us that 2F over H equals PH over 1. This is going to tell us that F is going to equal PH times H over 2. Right? Make sense? Great. Now we're going to plug this in for F right here. So we'll say PH times H plus PH times H over 2 equals 1200. Right? This is going to tell us that 3/2 PH times H equals 12,000, sorry. H has to equal 2/3 of 12,000 divided by PH, right? So 1/3 of 12 is 4, so this is going to be 8,000 over PH. Amazing, right? And this is going to be Anna's demand for housing, right? So demand from Anna is going to be 8,000 over PH. Great. So now we do exactly the same thing for Beth. And her problem is going to look very similar, right? Her budget constraint is just going to be the same thing except with a smaller budget. Right? We're going to have the same sort of picture here. Right? And we're going to have exactly the same MRS, right? Because she has the same preferences. So as before, right, we're only going to be able to find an interior solution. So let's look for that interior solution. We'll set her MRS equal to the price ratio. So 2F over H equals PH. As before, this is going to give us F equals PH times H over 2. Right, we'll plug that into her budget constraint. So we'll say PH times H plus PH times H over 2 equals 2400. H is going to equal 2 over 3 PH times 2400. H is going to equal, right, 1/3 of 2400, it's going to be 800, so that's going to be 1600 over PH. So what's our total demand? Our total demand is going to be Anna's demand, 8,000 over PH, plus Beth's demand, right, 1,600 over PH. So this is nice and easy, right? It's just going to be 8,000 over 1,600 plus 1,600, 9,600 over PH. And that's going to be our total demand. Does this make sense? Wanted to graph this thing, right? We would say if I have the amount of housing versus the price of housing, I would say that for Beth, right, at a price of, let's say, $10, she would demand 1,600 over 10, right, 160. Let's say 200, 400, 600. Right, she would demand 160 square feet at a price of 10. At a price of 5, she would demand something like 320 square feet. Right, she's going to have a demand curve like this. Anna is going to have a larger demand, right, because she's richer. So at a price of 10, she would demand 800 square feet of housing. Right? We're going to end up with a demand curve like this. Right, at a price of 5, she would demand 1,600 square feet of housing, which I haven't made enough room for on the board here. Right, I add these two together, I would say that at a price of 10, they're going to collectively demand 1,000 square feet of housing. Great, I'll fix that in a moment. So something more like this, right, where we've got Beth's demand here, right, Anna's demand up here, and we've got the total demand here. So let's say that we had a price of housing of $100, or I'm sorry, $10 a square foot, right? We would say that Beth would end up in an 160 square foot apartment. Anna would end up in an 800 square foot apartment, right? And overall, we would have 960 square feet of apartment being rented. Does this make sense? Great. Okay. So we're finished solving the problem now. I want to take a moment to talk about what we can learn from this sort of problem, about what consumer surplus is telling us, and really what marginal rates of substitution are telling us. So first of all, right, if we think about our consumer surpluses here, right, for both Anna and Beth, the consumer surplus is going to be the amount they would have paid for each square foot of apartment, right, versus the amount they actually had to pay, right, to the area above the price, below their demand curve, for both of them, right? If we think about their marginal willingness to pay for apartment space, what we're going to say is that the very last square foot that Beth lived in was worth exactly $10 to her. The very last square foot that Anna rented was worth exactly $10 to her, right? So in some sense, we can say that the value of Beth's last square foot of apartment is equal to the value of Anna's last square foot of apartment, despite the fact that Beth is living in a much smaller apartment than Anna, and Anna and Beth have exactly the same preferences. So in one sense, right, we might want to think, if we think about marginal rates of substitution, if we think about consumer surplus, we might want to say that apartment space is being allocated in an efficient way in this market, right, because of the fact that each square foot of apartment is going to whoever is most willing to pay, right? What this means, right, that the marginal apartment is worth $10 to them, right, is that both of them would be willing to trade that last square foot of apartment they rented for $10 worth of food, right, 10 units of food. So let's think about what would happen if we decided to take some apartment space from Anna and give it to Beth, right? Let's say that we're going to take 100 square feet away from Anna. So she's going to end up here. We're going to give 100 square feet to Beth, right? So she's going to end up here. Being very vague here. But let's imagine we've got similar amounts here. Are we going to increase or decrease consumer surplus? Well, clearly we're going to end up decreasing consumer surplus. The reason that I say that is that this 100 square feet to Anna was worth more than $10 to her. The 100 square feet to Beth was worth less than $10 to her, right? So if we think about the difference between the price and the amount that each person is willing to pay, right? This transfer to Beth actually has a negative consumer surplus right here, right? This transfer to Anna also reduces her consumer surplus by this amount right here. Essentially what we're doing is we're taking housing that had a higher dollar value to Anna than to Beth and giving it from Anna to Beth. In another sense, though, I think we've got to be very careful in looking at this and saying that we're creating an inefficient or bad outcome. The reason for this is these two have, right, by construction, exactly the same preferences, right? Exactly the same shape of preferences. And so in some sense, because Anna has more housing than Beth, I think it's reasonable to think that Beth actually values that 100 square feet of apartment more in absolute terms than Anna does, right? She has less housing. Housing has diminishing marginal returns, right? The value of housing is falling as we have more of it. Therefore, she's going to end up getting more value from that 100 square feet than Anna would. The reason that she's willing to pay less for that than Anna isn't because of how much she values housing, it's because of how much she values food, right? It's because due to her lower income, she has less of all other goods as well, and therefore the money she would have to part with to pay 10 square feet for $10 per square foot for an extra bit of apartment is worth more to her than that money is worth to Anna. So what we can say here, what our consumer surplus analysis can tell us here, is that in some sense, transferring apartment space between these two individuals would be less efficient than would be simply transferring income from Anna to Beth and allowing Anna and Beth to buy what they want to buy. Right? In some sense, Anna would prefer to give money to Beth that would make Beth as happy as this 100 square feet of apartment than she would to lose some of her apartment. But in another sense, we really shouldn't lose track of the fact that this transfer makes Anna worse off, but it does make Beth better off. Right? Beth is going to benefit from this extra apartment space. And in some sense, in some moral sense, we can't conclude just because of dollar values here that the amount of harm we've done to Anna is larger than the amount of good we've done for Beth. Right? In fact, it might be reasonable to think that the amount of good we've done for Beth is greater than the harm we've done for Anna. So this is something we're going to talk about in more detail, more depth later in the semester as we develop more tools. But the final point I want to leave you with is being able to do those sorts of comparisons, right, where we're not thinking about willingness to pay, we're not comparing things to dollars, requires us to take these utility functions much more seriously than we've been willing to do in the past, right? So that we can think in an objective sense about how much we've helped someone, how much we've harmed someone. Okay, done pontificating at you. I will see you in class. Thank you so much for sticking with me.